Hi, in this video I'll basically be checking the power consumption of the Raspberry Pi B model and the B Plus model. The claim is that Raspberry Pi B Plus model consumes a lot less power than the original B model. Now, the reason why I'm doing this is because in my setup I have the Raspberry Pi basically running off a battery. The system is supposed to be portable. The kiosk is supposed to be portable, and basically the problem in India is that we get a lot of power cuts. So I don't want the Raspberry Pi switching off, switching on all the time. I want it to be something that stays on for some time. Now there are a number of methods by which you can analyze the power consumption of a Raspberry Pi, but I'm going to be doing this via two methods. One of the methods is using a multimeter, and one of the other methods is using an oscilloscope. So I'll explain each step, and hopefully we'll have a conclusion at the end. Let's go. For this experiment, I have the V-in coming from a power adapter, and I have the Raspberry Pi connected at the output. In between I have a series of resistances. Now if you have 10 ohms resistances, 10 in parallel, that should come out to be somewhere around 1 ohms. Actually it should be exactly 1 ohms. Now if you have 1 ohms of resistances, and if I have say 1 amp of current by Ohm's law, I should have 1 volt of voltage drop across this. Now a lot of people would do this. What I have done here is, instead of having 10 ohms, I have 1 ohm resistances in parallel, 10 of them. So what I should get here is, instead of 1 ohms, I have 0.1 ohms in as a resistance. Now Ohm's law again follows. So instead of having if at a 1 amps of current, if I have a 0.1 ohms of resistances, Ohm's law says it should be 0.1 volt. Now I understand that this is really a small value. There's going to be a lot of noise in this, and the resistances I'm using are not, again, carbon film resistors, but if I have 1 amp of current flowing through, and if I have 10 ohms 1 ohm of resistances, that means there's a whole volt of drop across this. So if I'm applying 5 volts as an input, if I'm dropping 1 volt at my resistance, that means I'm getting only 4 volts. That means my Raspberry Pi has a very good chance of not operating the way it should, because if it's logic level 5, then it should have 5 volts as an input. So for that, I'm really not going to write a thesis paper on this, or a conference paper for this. So what I'm going to do right now is I'm just going to have carbon film resistors, 10 of them, and hopefully I should be having a good idea of how the Raspberry Pi is consuming power as it boots up, as it works, and as it goes through. Now my Raspberry Pi has a couple of things actually attached to it. It has the Enocean Pi module, and it also has a Wi-Fi adapter. Now this is a cheap one that I got from a local market. There are a lot of those available on Element 14 by the name of Wi-Fi, I think. You can go for that, but essentially I do not. This is basically a headless system for right now. I'm actually accessing it via SSH to actually analyze and work remotely. So this is going to go through my little circuit. So my scope is set to an entire of 10 seconds, so that I can have a plot of what is. So this is the Tektronix TBS 1202B EDU. For the Forget Me Not challenge, the 50 megahertz model of this particular scope is available. This one I got on a road test previously. So theoretically, if I have a 100 milliamps of current flowing through, and if I have a 0.1 ohms of resistance, I should get 0.01 volts, or about 10 millivolts. The accuracy of the resolution for this particular instrument is 20 millivolts per bit. I have actually added bandwidth limits to this because I'm trying to basically find out what DC. I'm trying to filter out as much AC as possible. I'm sure I'm going to get a lot of noise. So this is the Raspberry Pi. Let's start by connecting it, and let's run the system and go. There we go. So, yep, it's ramping up. So this cursor line, it should come somewhere. There we go. Let's see. You can see at the Raspberry Pi. There we go. That's my Wi-Fi turning on. That's the Wi-Fi adapter turning on. All right. So there we go. Cursor 1 set to 0. So you can see that it kind of ramps up initially as, let me just zoom in a bit, sorry. So, yep, so initially as soon as I connect it, it jumps up, then it ramps up as it starts to boot up. This is the point where it actually starts my Wi-Fi. I think there is a current draw for the Ocean Pi that can be noted here. There's a lot of noise in this thing. I'll just stop it before I refresh the screen. So it ramps up, Wi-Fi turns on, Wi-Fi attaches to my access point, and then it kind of levels out. All right, this is kind of leveling out at this point of time. Now, all of this noise is not only because of the AC stuff around. It's because of the switching power supply that I'm using for the Raspberry Pi. I'm not using the battery pack right now. I'm giving it as much current as possible. It's taking by my calculation that it's about 49.6 millivolts. So an accuracy if I multiply it by a factor of 10, that's what. So it's taking somewhere around 500 millivolts. 500 milliamps of current. It peaks up. The peak current would actually, I can say somewhere around. Yep, it goes up to 760 milliamps. At this point of time, it actually peaked up to 840 milliamps. So it has some amount of current consumption. All right. So I can see that it ramps up and it has somewhere around 500 milliamps of current. It doesn't go up beyond 1 amp, that's for sure. The next step would be to actually stress this particular system out, that I'm going to do next. For the next step, I'm gonna basically run an application called Stress. It's supposed to consume a lot of CPU power. It's supposed to give it some memory allocation, memory deallocation, and all that stuff should be happening in parallel. I have my Raspberry Pi connected by SSH to my tablet, and I have the command set up. So the first thing I'm gonna do is set the scope to run, and this is the normal power consumption, and execute. So Yep, there we go. I'm not exactly sure of what I'm supposed to be looking at as far as the stress program is concerned. I've set it to somewhere around 8 CPUs, 4 IOs, 2 VMs, 128 megs of power consumption. Now, this is still executing something. It jumps up and down. It's supposed to be taking some extra power. And there we go. Now it's done. Let me just there we go. So as far as the power consumption is concerned, as long as the CPU is running, even with the stress program, it doesn't jump up and down that much. I think my Pi is consuming a little more power just because I have a Wi-Fi card attached to it, and it's supposed to take, obviously it's supposed to transmit into the air, so it's gonna take some power. So I'm gonna, and this kind of readings from the scope with a lot of noise, I understand it's jumping up and down, so I can just I have a very good plot right now. So what I'm going to do next is I'm going to attach a multimeter and see exactly what the current consumption according to an RMS multimeter says. Right, at this point of time, the scope is out of the picture. I am basically bypassing the resistances as well. Right now what I have is just the USB cable split and the multimeter just connected in series and set to about 1 amp, sorry, 10 amps. So at this point of time, the Raspberry Pi is in quiescent mode. It's not running OpenHub, it's not running anything, it's just, you know, idle mode. So it's consuming 0.4 milliamps, so sorry, 460 milliamps, 0.4 amps. That means this is without anything running on this right now. All right, it's just because of the Ocean Pi that's connected to it and the Wi-Fi module that's connected to it. Now I'm gonna run the same stress command here, and let's see if it pops up. There we go. Whoa. Okay, so I have about 500 milliamps. That's the jump that I saw on the scope as well. It's now doing some processing, 0.46 amps. The negative sign is because the connections of the multimeter are in reverse, so the direction of current is reversed, but the amount of current is going to be the same, 0.46, 0.5. It's set to somewhere around 30 seconds, so it's going to run that much, 0.46, and there we go, finish. So it drops down to 0.41. So quiescent current of this particular Raspberry Pi Model B is 0.4 amps approximately. When it starts to stress out, it goes to about half an amp. Now that's not that big of a difference for me. I'm going to try and remove module to module, and then I'm going to see if I can see a difference in current consumption. Now I have the same Raspberry Pi connected the same way without the Ocean Pi module. You can see that from 0.41 amps it's jumped down. Oh, it popped up. It jumped down to 0.38 amps. That's 380 milliamps. So there's a small bit of a difference when it does have the Ocean Pi. I'm not sure. I'm gonna have to check the data sheet if that power consumption is actually justified. And the last step is to remove the Wi-Fi module. You can see the current dropped from 0.38 to 0.32. So not bad. I think the Wi-Fi module is not consuming that much power either. The last step would be to actually shut it down and see how much quiescent power it consumes. And now everything is running 0.41 amps. I'm gonna shut it down. I've just given a remote command to shut down. It fluctuates, it's executing, it's killing command, it's killing all the processes in the background, and down. 150 milliamps, 0.15 amps, just after shutdown. Everything else, it's just, you know, it's just taking power. The Ocean Pi module is taking power, but beyond that, nothing else is taking power. Shutdown state without the Ocean Pi module, and 0.11 amps, that's about 110 milliamps of current being consumed after it has been shut down. Alright, so these are the final numbers. My Raspberry Pi consumes a total of 410 milliamps with the Wi-Fi module and the Ocean Pi module. When it's a bit under stress, when there's a software stress on it, it goes up to 510 milliamps. With the Ocean Pi without the Ocean Pi module, 317 milliamps, which means approximately 40 milliamps is being consumed by just the Ocean Pi module. Then without the Wi-Fi and the Ocean, it consumed 320 milliamps. That means the Wi-Fi only is consuming 60 milliamps of current. And when I shut down the entire system, I have 150 milliamps of current being consumed. This means the Raspberry Pi alone is consuming 310 milliamps on an average when just running, not a lot of stuff. It's just standing there. So if you have OpenHub or something running, it's going to consume a little more current, but it's going to be somewhere around, I'd be prepared for half an amp of current to be drawn on an average with the Wi-Fi module and the Ocean Pi module and the OpenHub system running in the background. The next step would be actually to replace the Pi B with the B plus and see what is the actual current difference, because the linear voltage regulator is replaced by a switching regulator, which has a much more efficient system, and it should consume less power. So that will happen in a different video altogether. Thanks for watching.